In this video, we'll have to write a function to count the number of nodes of a single linked list. So how do you approach this problem? See, again, since you have been asked to write a single function to count the number of nodes, you will have to assume that the linked list is already provided to you. Now the linked list may be provided in any form. The linked list may be empty, and in that condition, the function may be invoked, or the linked list may contain exactly one node, and then the function may be invoked, or the linked list may contain multiple nodes, n number of nodes, and then this function may be invoked. So what you need to do is you need to consider all possible scenarios while writing the function. So what we'll do is, let me just explain the steps. Step number 1, we will start with a linked list. How will a linked list be provided to this function? Now a linked list will be provided to this function by passing the address of the first node of the list. How do you access the address of the first node of the list? You access the first node address by using the value of the head pointer. So in this function, in order to pass an entire list to the function, this function that we are about to write, we will have to pass the head pointer of the linked list whose node count we want to find. This function is supposed to find the number of nodes. So to find the node count, you will have to pass the head pointer of the linked list. Next thing is, you will have to check whether the list is empty or not. So if the list is empty, then there is no point in finding the count because the count is 0. So what we'll do is, we'll simply return the value of count to be 0. Next, what we'll check is if the list is non-empty. So if the list happens to be non-empty, then what we'll do is, we will start from the first node of the list and we'll traverse the entire list. And as we access one node after the other, we will increment the count of the number of nodes by 1. We'll have to keep a count variable, right? Which we will use to keep track of the number of nodes in the list. So this count variable will be initialized to 0. Then as we access one node after the other, if you look at my previous video, I showed you how to display a linked list. Here also, we'll have to access every node. In the previous video, we saw that we were accessing every node and printing its value. Here also, we will be accessing every node, but here, instead of printing the value, we'll be keeping a count of the number of nodes that we are accessing. So if I'm at the first node, I'll increase my count by 1. Then if I move on to the next node, again, I'll increase the count by 1. In this way, I'll keep on accessing the nodes one after the other. And ultimately, when I have completely traversed the linked list, I will stop my loop and I'll report the value of count. Since this is a function where you have to find the value of count, you can approach this function in two ways. You can either use a return type of void. If you use a return type of void for this function, then you'll have to find the count of the nodes and print the value of count in the function itself. Or you can make this function return the value of count to the function which called it. A function will be calling this function, right? You will have a main function. The main function will be calling this function. Let's call this function count nodes. It will call this function count nodes. And what will it do? It will simply pass the list and it will be expecting the output as the number of nodes in the list. So you can either print the number of nodes in the function itself, you can print the count in the function itself, or you can return the value of count to the function which called it. And that function will take care of that count value and either print it or use it for any other computation. So I guess this was the algorithm which is, I guess, clear to you now. If you have any doubts, what you can do is you can just rewind the video from the start and have a look at it. But even then, if you're unable to understand, I would suggest that you watch the video till the end. I'll be writing the function now. I guess after writing the function and after I do a dry run, things will be a lot easier to pick up. So let's start. Now, whenever you're asked to write a function which deals with a linked list, you have to define the structure. Just like we saw in the previous video, we'll be defining the structure first. So how do you define the structure? So you will be using this structure to define the format of a node. And in order to define the format, you will have to keep two things in mind. One is the data part of the node and the other is the link part of the node, which will be containing the address of the next node in the list. And if the node happens to be the last node of the list, then it will not contain the address of the next node because there is no next node to look out for. Instead, it will be containing the link part as null. The link part of the last node, remember, is always null. So this is what you would do first. You would first define the structure of the list. So you can pause the video and copy this down. Next, we'll go on to defining the actual function. So let's just define the function. So we'll call the function count nodes, and what I'll do is I'll make it return a value. You can also display it, but I'll make it return a value. So it will return, obviously it will return an int value. So the return type of the function, because if you're counting the number of nodes, the count of the number of nodes will always be an integer, right? You will always have either 3 nodes in your list, or 30 nodes in your list, or 500 nodes in your list. You can never have a fractional value of count. You can never say that I have 5.6 nodes in my list or 2.37 nodes in my list. The count of the number of nodes will always be a positive integer. Okay, so that's why the return type of the function will be int. Let's call the function count nodes. And in this function, I'll be passing the entire linked list. So how do I pass the entire linked list? I pass the head pointer. So I'll have a variable called ptr, which will be getting hold of the head pointer value. Now, the first thing that I need to do is I need to create a variable called count, which will be holding the value of the count of the number of nodes. And obviously, initially, the value of count should be 0 because I don't know how many nodes are there in my list. So I'll start with the value of 0. Next that I need to do is I need to check. So what will I check? If, okay, what I'll do is instead of using ptr, I'll use h. I'll make use of ptr here itself. So what do I have to check first? I'll have to check whether the list is empty or not. And how do you check whether a linked list is empty or not? If the starting node value, if the starting node address which is contained in my head pointer, if that contains null, so this is the condition for is empty list. This is the is empty list condition. So if it happens to be null, then what I'll do is I'll simply say that the value of count, or I'll have one return statement. So here what I'll do is I'll simply print out a statement. So I'll say printf list is empty. Okay. So I'll do this. Now, so I'll close off the brace here. Now, if the list is not empty, that means it contains a few nodes. Now I have to count the number of nodes. I'll not move my head pointer for obvious reasons. I've explained this in the previous videos as well. You can have a look that we'll never move the head pointer, because if the head pointer is moved, a portion of our list will be lost. As a result, we'll keep the head pointer intact. Now h is a copy for the head pointer, right? So I'll keep it unchanged. Instead, I'll use a second pointer. I'll call it ptr. So struct node star ptr is equal to h. I'll start off from the first node. I'll start my count from the first node, and the first node address is contained in h. So I'll take the value of h and I'll store it in ptr. Now I'll run a loop. So I'll check. What is the condition for checking a linked list till the end? So I'll have to check if ptr is not equal to null. So this loop will enable me to traverse the entire linked list like we saw earlier. So if ptr is not equal to null, I'll simply increment the value of count by 1. And after incrementing the value of count by 1, what do I need to do? I need to move to the next node. And how do I move on to the next node? I'll say ptr equal to ptr arrow link. So this will take me to the next node. This will take me, go to next node, okay? This will take me to the next node. So go to next node. This will take me to the next node. And now after I'm done with counting the number of nodes, so this will bring an end to the else part as well. What will I do? I'll simply return the count. Like we saw, the return type of this function is int. So I'll have the last statement as return count. Okay. So this will bring an end to the function. Now, if I do a dry run of this, let's say I have a list. Let's say I have a list containing 4 nodes. Okay. Now, let's say the addresses are 10, 20, 30 and 40. These are the addresses. So this will contain 20, this will contain 30 and this will contain 40. If you have understood the code, you can stop the video here. But if you want to look at how things work, or if you're unsure about how this program will behave, you can just look at this dry run. Okay. So here, let's say there is 3, 7, 9, 12. And now this is pointing to this is pointing to this, and this is pointing to this. Now 10, see, 10 is contained in head. Head contains 10. Now see, this function will not create any linked list, mind you. This function will simply count the number of nodes in any linked list. So it will not create any linked list. I am assuming that such a linked list is already created for me. If I have to implement this program as a whole, then I'll have to write the function for creating a list. So for creating a list, we'll have a separate function. Now, how do you create a list? You create a list by inserting nodes one after the other. So I'll take up insertion functions, then you will see how the list creation takes place. But for now, you can assume that a linked list is already available, and that linked list is passed as input to this function. So how do you pass a linked list as input? You pass a linked list as input by passing the head pointer. So how would this function be called? This function can be called like this. Let's say I have the name of the function. The name of the function is count nodes, and then I'll pass the head pointer, and I'll keep a track of the return value. Since this function returns a value of int, I need to have a variable on the left hand side of the function call. This is the function call. I need a variable on the left hand side of the function call because the function returns an int value. So the return value of this function will be stored in C. Now, the moment I pass head from the main function, this gets copied to H. Now, H also contains 10. So now H, which is a local variable to this function count nodes, that contains 10. Now, what am I doing? I'm doing count equal to 0. So initially my count is 0. Now next, I'm having another pointer called PTR, and PTR is assigned to H. So PTR now contains 10. So PTR now contains 10, and it is as if PTR is pointing to the first node. Now I'll check if H is equal to null, but H is 10. So this condition is not satisfied. So I'll come to the else part. In the else part, I have a loop. So what is the loop telling me? While PTR is not equal to null, what is the value of PTR? The value of PTR is 10, which is indeed not equal to null. So the condition is satisfied. So you come inside. You increment the value of count by 1. So count is 0. Now count becomes 1. And now you're saying you need to go to the next node. How do you go to the next node? In order to go to the next node, you need to access the link part of the node to which PTR is currently pointing. See, PTR is currently pointing to this node, If you access the link part of this node, it will take you to the next node. So that's why we have PTR equal to PTR arrow link. PTR arrow link means access the link part of the node to which PTR is pointing. So the link part of the node to which PTR is pointing is 20. Take that value and store it in PTR. So now PTR gets a value of 20. So it is as if PTR is now pointing to this node. Now again you go back up. So PTR is not equal to null. You come inside the loop. You increment the value of count by 1. So count becomes 2. Then again PTR equal to PTR arrow link. So access the link part of the node to which PTR is pointing. PTR is pointing to this node. So access its link part. Its link part is 30. Store it in PTR. So PTR gets a value of 30. Because the link part of the node will contain the address of the next node. So the link part of this node contains the address of the next node. After I am done with this node, I need to go to the next node. And in order to go to the next node, I can simply access the link part. So this will take me to the next node. And again, I'll go back up. PTR is not equal to null. So condition is satisfied. You come inside. You increment the value of count by 1. Now count becomes 3. Next, PTR becomes how much? PTR becomes 40. So PTR is now pointing to the last node. Again, you go back up. Obviously, 40 is not equal to null. So you come inside, you increment the value of count by 1. So count becomes 4. Then again, PTR equal to PTR arrow link. Now look at this. What is PTR arrow link? PTR arrow link is null. PTR arrow link. So PTR is pointing to this node. Its link part is null. You assign it to PTR. So PTR now is not pointing to any node. PTR is now not pointing to any node. As a result, this condition, while PTR not equal to null, is not satisfied. You come out of the loop and you return the value of count. What is the value of count? 4. And indeed, I had 4 nodes in my list. So now this return value, what will happen? This count, which is currently 4, will be returned at the function call, and it will be stored in the variable on the left hand side of the function call. This was my function call, and since count value is returned, that value will be stored in C on the left hand side of the function call. So this will give me a correct count of the number of nodes present in my linked list. So I hope this helps. If you have any doubts, please feel free to comment in the section below. Thank you.